Hello everyone, I'm Xiaoling Wang from Dalian University of Technology. In this video, I will introduce our recent work, Bilevel Learning of Task-Specific Decoders for Joint Registration and One-Shot Medical Image Segmentation. This paper addresses the challenge of achieving one-shot segmentation through joint registration, a crucial task in medical image analysis. Registration provides pseudo-labeled data pairs for segmentation through spatial transformations, while segmentation offers anatomical structure information to enhance registration. The motivation for our research stems from the limitations observed in existing methods. Current deep learning approach often use two independent encoder-decoder structures for registration and segmentation tasks. This framework requires longer training time to adapt to multi-center data. Moreover, these methods typically employ a naive alternating training strategy, which can result in unstable learning and suboptimal performance. To address the above problems, we adopt a fixed shared encoder architecture, which freezes the pre-trained encoder during the training process and only trains the decoder to achieve fast adaptation to multi-center data. Specifically, we model the coupling between the registration decoder and the segmentation decoder using bilevel optimization to guide the collaborative optimization process by simulating the coupling dependencies. Registration is treated as the upper-level task, and segmentation is considered the lower-level task. By formulating the optimization problem hierarchically, we exploit the intrinsic relationship between registration and segmentation, thereby improving the overall model performance and stability. This hierarchical approach allows us to optimize both tasks simultaneously. We designed the iterative gradient response algorithm to address the nested optimization challenge inherent in bilevel frameworks. The registration head is now optimized using both the direct gradient and an optimal gradient. The naive alternation does not contain the optimal gradient term, meaning that compared to the conventional gradient descent model on the left in the figure below, the coupled optimal gradient response derived from the segmentation dynamics can provide feedback to the optimization process of the upper registration task in each round of iteration, which is the vertical line that points from the segmentation loss to registration loss. The appearance conformity constraint, or ACC, is designed to avoid the texture gap between unlabeled images and a single labeled image. By preventing error accumulation and increasing data diversity, ACC also contributes to a more stable and effective training process. To validate the effectiveness, we conducted extensive experiments. Our method shows rapid adaptability to new datasets due to the fixed shared encoder. Additionally, our approach achieves a more stable training process and higher performance compared to naive alternative training process. Our ablation study examined the impact of different components on overall performance. Compared with the state-of-the-art, our method demonstrated superior performance in both registration and segmentation tasks. The visualization results highlight that our method produces outcomes closer to the ground truth in both segmentation and registration tasks. This visual validation further supports the quantitative improvements observed in our experiments. In conclusion, BiJROS introduces a bilevel optimization framework and an iterative gradient response algorithm to simultaneously enhance the performance of joint registration and one-shot medical image segmentation. The incorporation of appearance conformity constraints further improves data diversity and training stability. Extensive experiments validate the superiority of our approach over existing methods, highlighting its potential for broader applications in medical image analysis. Thank you for your attention.